Now let's start with exercise 1.3. But before that, we should know the understanding of the exercise. Okay, so we'll start with first conditional statement. A general statement we need to prove because geometry is all about reasoning and reasoning. Now reasoning are two types, normal reasoning and logical reasoning. Sometimes you require a logical reasoning. Example, what will come after 4? 5 or 6? You will say after 4 definitely 5 will come. Am I right? But logical reasoning says that after 4, 5 and 6 both will come because 6 is not coming before 4, right? It is coming after 4 only. So after 4, 5 and 6 both number will come. That is called logical reasoning. Hope you understood what do you mean by logical reasoning. Same here, we need to think logically now, more of logically, because you are no more kid. Now you are adolescent, a teenager. So let's start with conditional statement. What are the conditional statement? Any statement stated in the if and then form is said to be conditional statement. Okay, so wherever if and then is applicable, such statement are called conditional statement. If you come late in school, then you will be punished. So this is a conditional statement in which the one is condition and the other is its consequent. Next, the part of statement which follows if is called antecedent. So whatever the statement comes after if is called antecedent, and the statement which follows then is called consequent. It is called consequent. Example, general statement is two intersecting lines are contained in one plane. Two intersecting line, let me draw and explain you. Two intersecting line L and line M are intersecting because they intersect at this point. They contain in a same plane. They are present in the same plane, in the same square or same any flat surface called plane. Now the conditional statement, if two lines are intersecting, then they form one plane or they contain in one plane. If two lines intersect each other, then they are contained in one plane. This is a conditional statement. Now what is antecedent? The statement which comes after if, right? Now which follows if is called antecedent. Till then, okay? So here antecedent is if two lines intersect each other. As this is antecedent. And what is the consequent? Consequent means the statement which follows then. So then they are contained in one plane. Then they are contained in one plane. Correct? So the part of the statement which follows if is called antecedent, and that which follows then is called consequent. Hope you understood. Now converse of statement. Converse of statement is a new term, but it is very easy. Just reverse the consequent and antecedent. Consequent and antecedent, just you need to reverse. Means then, instead of then, here if will come, and here instead of if then will come. If lines are contained in one plane, then two lines intersect each other or they are intersecting line. I'll repeat, if instead of then what we have to write? If. So if lines, they means what? Lines, intersecting lines. So if lines are contained in one plane, then those two lines intersect each other. That is antecedent and consequent. Next is converse statement. A statement obtained by interchanging the antecedent and consequent is called converse of the original statement. What do you mean by converse statement? A statement obtained by interchanging the antecedent and consequent. Understood? If and then will be replaced with each other. That is called converse of statement. Example of this. I'll write that example. Now instead of then what will come? If. So if they means what? Two lines. If two lines are contained in one plane, then now instead of if what will come? Then two lines intersect each other or are intersecting lines. So this is converse statement. So hope you understood. This is the basic. Hope you understood it. So let's try more example, right? Now more example in activity. A general statement is a triangle has three sides. So what will be conditional statement? In conditional statement we have to use if and then. So if a figure is a triangle, then it has three sides. Simple. Conditional statement will be if a given figure, because triangle is a figure, right? Figure is a triangle, then it has three sides. This is the conditional statement. Now antecedent. What is antecedent? The statement which come after if. So after if a given figure is a triangle. So antecedent is if a given figure is a triangle. Now consequent. Consequent is nothing but the statement which follows then. So then it has three sides. Now converse statement. You know very well what is converse statement. Just interchange of if and then. So instead of then, now if will come here. Instead of if, then will come. So we'll start with if. If, it means what? A figure. If a figure has three sides. So if a figure or a given figure has three sides, then it is a triangle. Then the given figure is a triangle. So we will not repeat that figure. So then it is a triangle. Isn't it easy? The next one, general statement. An equilateral triangle has three congruent sides. Now conditional, if and then. If a triangle is an equilateral triangle, or if a figure is of equilateral triangle, anything will do. So I will write, because equilateral triangle is a type of triangle, so I will use what? Triangle. If a given triangle is an equilateral triangle, then it has three congruent sides. So I will write, if a given triangle is an equilateral triangle, then it has three congruent sides. Now antecedent and consequent. What is antecedent? The statement coming after if. So I'll write, if a given triangle is an equilateral triangle. Consequent, then, statement coming after then it has three congruent sides. Now converse statement. What will be converse statement? Just interchange of if and then. So here if will come, here then will come. So if, now it means a triangle. If a triangle has three congruent sides, congruent sides, then the given triangle is an equilateral triangle, or then it is an equilateral triangle. So this is converse. Isn't it easy? The next one is general statement. An isosceles triangle has only two congruent sides. It is just like the previous one. Here all three sides were equal. Here only two sides are equal. So the conditional statement. If and then, if a triangle is an isosceles triangle, if a triangle is an isosceles triangle, then it has only two congruent sides. Then it has only two congruent sides. Correct? So if and then we have used. Now antecedent. What is antecedent? The statement following if. So antecedent. If a triangle is an isosceles triangle. Consequent. What is consequent? Statement following after then. So it has, okay, I need to write then also. So then it has only two congruent sides. Next is converse statement. Converse statement. Now what will come in converse statement? If a triangle has three congruent sides, that it is an equilateral. Okay, that was here. Now here if and then, the reciprocal of if and then, the interchange of if and then. Here if will come. So if it means a triangle. If a triangle has only two congruent sides, if a triangle has only two congruent sides, then what? Then it is antecedent. Then a triangle is an isosceles triangle. Then it is an isosceles triangle. And this is the end of activity. Hope you understood and you enjoyed it. So let's start with now exercise 1.3, which is very small. Now logical reasoning. Postulate the self-evident geometrical statement which are accepted by all. These are called postulate. Postulates are also known as axiom. It means it doesn't require any proof, or you cannot prove it. Okay, so they are accepted universally. Like sun rises from east, it is the universal fact, right? Wherever the direction from which the sun rises, we call it east direction, right? East. So it doesn't require acceptance, or it doesn't require proof. It is universally accepted. So this thing are called postulate. Some of the geometric postulate given by Euclid are: there are infinite line passing through a point. Example, if I give you a point like P. Now how many line can pass through point P? Answer, definitely C. One line, then second line, third line, fourth line. Same way we can draw fifth line, sixth line, seventh line, eighth, ninth, the infinite lines. How many lines? Infinite lines. So there are infinite line passing through a point. So this is a statement which we cannot prove logically. So we have to accept it as a fact. Just by drawing we can prove, but we cannot prove logically with the reasoning. So this type of statement are called postulate. These postulates were given by Euclid. There are more postulates which were given by other contemporary mathematicians. Next, there is one and only one line passing through 2 points. Example, now 2 points, first point and second point, point A and point B. Now how many lines you can draw passing through point A and B both? So answer definitely one and only one line. Correct? So one and only one line. So this is also statement just by a diagram you can prove. You cannot prove by any other evidence. The next one. So this is also called postulate. A circle with the given radius can be drawn by taking any point at its center. Now if I want to draw a circle of specific radius, I'll take this much radius. It can be drawn by taking any point at the center. Definitely we can draw circle only by keeping this point at center. So this is a circle, correct, and this is the center. So we have to use a center first to draw a circle. We cannot draw a circle without using center, right? Exact circle we cannot draw without using center. So that is also a postulate. The next one, all angles are congruent to each other. All right angles are congruent to each other. Right angles means angle which are of 90 degree. See, this angle is also a right angle. So I'll draw a few right angles. Here angle A, B and C, and angle P, Q and R. These both are right angle and definitely they are 90 degree. So now when the angle measurements are equal, the angles are equal. So it means all right angle are congruent. So this is postulate, doesn't require any proof. These are called postulate. Now final postulate. If two interior angles formed on one side of a transversal of two lines add up to less than two right angle, it means two interior angles, this is a line, and two interior angles, the first and the second. We have two interior angles. These are interior angles, even other two are also interior angles. If two interior angles formed on one side of a transversal of two lines add up to less than two right angle, right? This is acute angle and this one is also acute angle. So both of them add less than right angle, right? Both of them are less than 90 degree because both are acute angle. Both are add up to less than two right angle. Two right angle will be of 180 degree. 90 plus 90, 180 degree. It is less than 90 degree. It is also less than 90 degree. Means both angle are less than two right angles. Then the lines produced in that direction means in which they are present, this direction, intersect each other, right? The line will intersect. See, line I have produced and this line is intersecting each other at this point. So this is also postulate. So these are some example of postulate. These all postulates were given by Euclid, a mathematician. The next one, theorem. Properties which we can prove logically are called theorem. So let's prove one theorem. Okay, and then the second is proof. The logical arguments made to prove the theorem are called proof. Sum of all angles of triangle is 180 degree. This is the statement. Now we need to prove that so all the angles of a triangle is 180 degree. So first we will write given. Given means antecedent, all sum of all angles of triangle. So if a figure is a triangle, then consequent. If a figure is a triangle, then sum of all angle is 180 degree. Then sum of all angles is 180 degree. This is consequent. Now we will prove. Now given a figure is a triangle, so we will draw a triangle. A triangle with angle A, B and C. This is angle A, this is angle B and angle C. Now we have to prove angle A plus B plus C equal to 180 degree. Consequent, then sum of all angle is 180 degree. That we need to prove angle A plus B plus C equal to 180 degree. Now how to prove it? It is very easy. How to prove it? For that, first construction, we have to construct here line L parallel to base of the triangle. Line L parallel to base of the triangle. And we will name these angles as angle M and angle N. Now you know that angle M, angle A and angle N, they form line, linear pair, angle in a straight line. So we know that. Now we are doing proof, logical argument. What is proof? The logical arguments made to prove the theorem. Arguments we will make. Now for proof we will write angle M plus A plus angle N equal to 180 degree, right or not? And what is the reason? Angle in a straight line, angle in a straight line, right? It is 180 degree, angle in a straight line of 180 degree. Now angle M is congruent to angle B. Alternate angle, last year you have learned when two lines are parallel, alternate angles are congruent. So angle M congruent to angle B. So instead of M we will write angle B. Angle A we will write angle A only. And instead of N, angle N, right? This is also alternate angle, Z shaped, reverse Z but Z shaped. So N is congruent to C. So instead of N we can write C equal to 180 degree. Correct? And that is A plus B plus C. Just we are rearranging it, equal to 180. So this is proved. ABC equal to 180 is proved. We have proved it. So by this logical reasoning, logical arguments, we can prove certain things. The things which we can prove are called theorems. And these logical arguments which we are representing is called proof. Hope you understood. One more. Vertically opposite angles are congruent. Now what do you mean by vertically opposite angle? Now these are two lines which are intersecting at this point. Four angles are formed: A, B, C and D. We need to prove vertically opposite means A and C. So we have to prove angle A congruent to angle C. Angle B is congruent to angle D. Now first we will write in the form of antecedent and consequent. Antecedent, if angles are vertically opposite angles. If angles are vertically opposite angles, then consequent. Then they are congruent. Then they are congruent. Okay, so we will prove angle A and angle C are congruent, angle B and angle D are congruent. So how to prove it? So for that we have to use proof. Now we know angle A and angle B. A and B form a straight line, and we know angle in a straight line add up to 180 degree. So A plus B equal to 180 degree. Next one. B plus C. This also form a straight line. B and C also form a straight line. So B plus C is also equal to 180 degree. Reason, angle in a straight line. The reason will remain same. Now as we know both are 180 degree, sum of both the angles is 180 degree. So I can say A plus B equal to B plus C equal to 180 degree, because this addition of these two angles is 180 degree. It means they are equal. Or one more rule, if right part of the two equations are equal, it means the left part are also equal. Now this B is common from both the sides. The thing which are common from both the sides and both have same sign will get cancelled. So A equal to C. That means A is congruent to C. So it has been proved. And similarly we can prove B is congruent to C. So this is called proof. What it is called? Proof. So what is theorem? Theorem means which we can prove. The properties which can be proved logically are called theorems. And what do you mean by proof? The logical arguments made to prove the theorem are called proof. So this is proof and this statement are theorem. Now it's time to exercise 1.3. It's very easy. Write a following statement in if and then form. If and then form. The opposite angles of a parallelogram are congruent. It means if a quadrilateral is a parallelogram, then their opposite angles are congruent. So I will write the statement in if and then form. So I'll write answer or solution. If a given quadrilateral is a parallelogram, then what? Then their opposite angles are congruent. Opposite angles are congruent. And if we want to write converse, then here if will come, here then will come, here if will come, here then will come. The next one, the diagonal of rectangle are congruent. So can you guess the answer? Which figure is this? A rectangle. So if a quadrilateral is a rectangle, then the diagonals are congruent. So if a given quadrilateral is a rectangle, then its diagonals are congruent. Then its diagonals are congruent. The next one, if an isosceles triangle, the segment joining vertex and the midpoint of the base is perpendicular to the base. This is lengthy, but it is not difficult. Answer: if a triangle, which triangle is this? Isosceles triangle. If a triangle is an isosceles triangle, then the segment joining the vertex and the midpoint of the base is perpendicular to the base. And this is the end of first sum of exercise 1.3. Write the converse of the following statement. So first we have to write in if and then form, and then we have to convert a converse by replacing if with then and then with if. Write the converse of the following statement, 1 mark each. The alternate angle formed by two parallel lines and their transversals are congruent. So first the statement how if will come. If an angles are formed by parallel lines and their transversal, then alternate angles are congruent. Correct? So if answer, if the alternate angle are made by two lines and their transversal are congruent, then the two lines are parallel. The two lines are parallel. Number 2, if a pair of interior angles made by transversal of two lines are supplementary, then the lines are parallel. Now instead of then, it is very easy. Instead of then, what do you write? If, and here then. So if lines are parallel, if lines means two lines, right? Two lines are parallel. Answer: two lines are parallel, then no, and our transversal is also there. So if two lines are parallel and intersected by transversal, intersected by transversal, then the pair of interior angles are supplementary. The pair of interior angles are supplementary. The pair of interior angles are supplementary. And the last one, diagonals of rectangle are congruent. So if a quadrilateral is a rectangle, diagonals are congruent. Now converse. Answer. Right? So if a quadrilateral is a rectangle, then diagonals are congruent. So if diagonals are congruent, if diagonals of a quadrilateral are congruent, then it is a rectangle. And this is the end of exercise 1.3. In next video we will start with problem set 1.